Welcome to an example in which we're converting a complex number here from polar to rectangular form. So let me rewrite this a little more neatly. This is 9 times the cosine of pi over 4 plus I sine pi over 4. So how do we, and this is called polar form. Polar form. It's also called trig form. Goes by either name. I'll usually call it polar form. Why is it polar form? Well, it has an r. This is the r, and this is the theta, the angle. So it's like a polar number, like a polar coordinate with r and theta. I want to change to rectangular. So to change to rectangular, meaning, and what's rectangular? X and y. Just distribute, and then hit the buttons on your calculator. So you take that 9 and go boom and boom. So we get 9 cosine pi over 4 plus I times 9 times sine pi over 4. Now, they want decimal answers on this one. So you can just use your calculator, but make sure calculator in radian mode. If you're going to use your calculator. Why? Because this is a radian angle. It's not degrees, right? I don't see any degree symbol. You could change it to degrees. This turns out to be 45 degrees. You could change it. I'm getting that because I just plugged in a 180 right there for pi and divide by 4, and it becomes a 4. These are both 45 degree angles, so you could change to 45 and then use your calculator in degree mode, or you could just let it stay as it is and use your calculator in radian mode. Either way, be careful. So I'm getting 6.36 and rounded to, I don't know how many places, so I'll just go 36396. I'll put a bunch. It never said how many places. Plus I, and then 9, and I'm going to do that. That's 6.36. Oh, same thing, 396. We usually put the I in the back. It doesn't really matter. So there it is. There is the same complex number in rectangular coordinates, right? This is like an X and a Y because on the complex plane, remember, the real part is X-axis and the imaginary part, the I part, is the Y-axis, goes up. Those would be the exact same dot on the complex plane or the rectangular plane. This is just like changing coordinates. Except for changing a whole equation, but it's really the same exact thing. There we go.